Linh-chan and Dimi-chan, write code. Then we're going to import, before I forget, we're going to import AV Foundation. And AV Foundation lets you work with video files in a super easy way.
Here's another comment.
Um,
This person asked, have you got a degree in programming or something? If yes, did that help with the programming languages you learned after your degree?
I did not. I am completely self-taught since the ages of 10/13, depending on what programming language you're going to count as what I taught myself. I went to school and learned about linguistics. I guess that's language related, but not at all programming language related. I would say that get a degree in something that that can show that you completed college, and if you have any experience doing programming, that will be enough to actually get a job doing programming, as long as you have a degree that shows that you can finish something, basically. So you'll see on most job applications, it's always a degree or equivalent experience, because this is getting more and more common, basically. So we are also going to have a property for our AV asset, and an asset represents the video file itself. So we'll start with these two properties and we'll go from there. So now let's add some queue management code, so that way we can actually work with an asset and start doing stuff. So in open file, we get an actually open the file now. So if, I meant to put this here. Sorry about that. So when we open the file, that's when we check if we didn't launch yet, which means that we didn't get to this point yet. Then we'll say that we're going to close on finish, not in open document. Sorry about that. But when we do open the file, we're going to grab an asset from the file name that's specified. So we're going to go and say AV asset. Oh, we need to import here too. Did I ignore it into, yeah. So let's import AV Foundation again, because we need to import everything. And let's also import our job file that we created earlier, so that way we can reference it. So we'll make an AV asset, and we will be making an AV URL asset, which I believe you can just make it from an AV asset, but we'll specify directly. And a URL asset is basically an asset that's backed by a URL. So we're going to allocate the memory and initialize it with a URL. And the URL, we're going to be basing it off of the string-based file name. So we're going to say NSURL file URL with path file name. Come on, autocomplete. Be my friend. I'm used to working on a faster computer, so I'm typing faster than Xcode, which I hear is not uncommon anyways. So we are going to specify that we want precise timing, because we are going to be asking for individual frames directly, and it's good to just get that out of the way. Did I do too many? Just enough brackets? Yeah. Okay, so now we have our asset, and we can go ahead and make sure that the asset is valid. So we'll say if asset, and because we might actually load a video file, but the video file might be empty, so we want to make sure that it has some video in it. So we can say asset tracks with media type, and then we're going to say AV media type video. So we're not interested in most others, and we just want to make sure that there is some video inside of this quote unquote video file. Since it can be an MOV. MOVs can contain all sorts of wiki wacky stuff. So I don't know what wiki wacky is. I just made that up. And then finally, we do also want to verify that we were able to load the tracks. The tracks object. So we'll go ahead and specify the tracks property right here, and we'll say and error. So that means we need to make a new error object. NS error equals no. So that will hold our error for us if we do have an error opening the file, which we can go ahead and use in an alert afterwards. And we are going to make sure that the status, so again, we're checking the status of the property. We want to make sure that the status is equal to the tracks are loaded, basically. So AV key value status loaded. There we go. And that's all the checks that we're going to do. And then we're going to go and create our job right in here. But first of all, since we do have that error, I do want to take care of it so we don't have to worry about it later. So if there was an error loading the asset, that means the asset was valid, but there was an error at one point. We are going to go ahead and show an alert. So NS alert. And this is one of those standard alert dialogues that says, are you sure you want to do this? And then you have to say okay or cancel, kind of thing. And we're going to take the cheap way of just saying alert with error and hope that the error has enough information that the user can run with that. If you are making this application to sell it, I would probably make a custom error, which we are going to do in the case where we don't have an error, to handle that situation. But for now, this should do. And then when we don't have an error, but the asset still didn't work, so to make sure that we never get there, we'll return yes right here. So if there is an asset, we're done working at this point, basically. If there is not an asset for whatever reason, we check if there's an error. And if there's no error, we will go ahead and make a custom alert dialog because we can't just pass error into it. So we'll make that alert, and we'll just make it the standard way. NS alert, allocate, initialize. So again, this is the same thing as going like NS alert, like that in many other languages. Objective-C just has you allocate the memory first because you can't forget to do that. And then we'll set the message text of the alert to something generic because we have no idea what went wrong. Could not open file. And then we'll run the alert dialog. So alert run modal. So what run modal means is it's basically going to take control of the application until we deal with the alert. So preventing the user from accessing menus, doing anything else. That's what modal means. Modal? I think it's modal, but who knows? And then once we if we do succeed, over here, we will go ahead and make a new job. So we'll make a job, and we'll just do a standard way, same as we did with the alert. So allocate init. You'll be seeing a lot of alloc inits in Objective-C. There is a new somewhere around here that you can use instead of allocate and then init, but I haven't seen many people use it, so you're more likely to see this kind of pattern instead, which I just got used to. And then we'll say job.path, one tab too many, and we'll specify the file name that we got before, and then we'll give it our asset that we loaded and verified is valid. You could probably organize this in a different way, so like job, allocate, and then init with file, and then if the file fails for whatever reason, you return nil, and then you deal with the error. This is just much simpler and quicker, which is why I did it this way. Finally, we want to be able to add the job to somewhere to get it started, so we will be managing a queue. So before we get to that point, we'll need to store our queue somewhere. So we're just going to make a new array that's going to hold a queue. So NS mutable array because we want to change it, so it needs to be mutable. And we'll call this our queue. And let's also have a pointer to the current job for those that are for when we need to know what the current job is. That way we don't start many jobs all at once because there's only so much computing power. And I don't believe multiple resources can use the transcoding at the same time. So we'll just push one at a time to make sure everything is going smoothly. And then, so that way we can later show it in our queue window. We want to have a reference to all the jobs. So only the jobs that are left will be on the queue. The current one will be here. And then we also want a reference to everything. So we'll just make a general property to hold this. And since we're lazy, we'll just use a mutable array. You typically shouldn't have mutable arrays as properties. They should always be arrays, and they should also be specified as copy. So that way no one goes in and modifies your mutable array without you knowing. But this should do a simple app like this. So we'll make a jobs array, and then this will hold all our jobs. And finally, we will want some methods to start manipulating our queue. So I figure we only really need two. We need an add and a queue next job. So let's go ahead and make both of those. So let's make so it doesn't return anything, and we'll add our job to the queue. Add job to queue, such a weird word. And then we specify we want one parameter, which is our job. And what this is going to do is we are going to add the job to our queue, and we are going to reload our table and start any jobs that are pending. So we'll have this method, and we'll have one more that's called queue next job. And that's going to check if we have a current job, and if we don't, we're just going to go and make a new one. So we'll go ahead and queue next job, excuse me. So queue next job is simple, so we'll go ahead and write it right away. So if we don't have any current job, and there's stuff in the queue, so queue.count, then we will go ahead and set the current job to the first item on the queue, which was basically the first item that was added to it. So equals queue dot count. No, not that count. I'm typing first object. So this is going to give us the first object, or if the queue is empty, it will give us nil. But we're never going to have an empty queue here because we check if the queue has stuff in it. So this is a shorthand for that. Just a little cleaner. And then we're going to get rid of the first item in the queue. So queue remove object at index 0. There is a remove last object, but there is no remove first object for whatever reason. So we'll just say we want to get rid of the first one. And then we'll start the job, which we are not capable of doing yet. And then we'll do some interesting things where if, we can do that afterwards. Okay, so we'll basically check if we're doing a current job, and if we are, we won't do anything, and if we're not, we'll start a job basically. And then in add job to queue, we can go ahead and queue the next job. So that'll be the last thing we do after we add it. And that will basically take care of if there's a job running or not. And before we do that, we'll just add it to the queue. So queue add object, and we'll add our job to it. And we'll be sure to add it as well to our jobs array. So add object and job. So right here, jobs has an underscore because it is a property. So the underlying variable is underscore jobs, whereas these are directly defined. So that's why there's that discrepancy there, but it shouldn't matter all that much. And then finally, we can go ahead and add the job that we just made. So we can say self add job to queue, and we can use the job that we just made right there. And then we can go ahead and queue the next job whenever we open a file. So for example, right here, we succeeded. So that will queue one automatically because it will go to application open file, and open file does end up queuing a job eventually through add job to queue. But if that fails for whatever reason, we can go ahead and force any waiting job to complete. This is relatively safe since we're single threaded. I would take more care if we weren't, but this should do just fine. And then similarly here, if we failed to open the file, we'll just start the next job right around there. And we'll be sure to return no if we fail to open the file. I don't know what returning yes or no does for the system. I guess it modifies its expectations of that file for your application. I'm not too sure if it actually does anything. They say you should do it, so we'll just do it. And this should put a job on the queue and get us moving. So let's update the user interface to show this. So we'll go ahead in here, and what we want to do is use bindings to hook all this up, since bindings makes it easy, quote unquote. So first we'll grab an array controller. So our array controller, we need to configure it. So the class is going to be a job class. Then we have to go in here and bindings, sorry. For the content array, we are going to bind it to our delegate, and the path is going to be jobs. So remember we made that jobs array before, so this array controller is going to check if there are any changes to that jobs array and then update this table view accordingly. Similarly, we want to we want to make sure that the table is connected to the array controller. So we go ahead and select our table way down there, and we can go ahead and say the contents, we're going to bind it to the array controller to arranged objects. So this should, the minute we add a file to our queue, it should update the table view and display the update. So if we go ahead and say that should open and put an item here, but it's not. So you may end up scratching your head, as I did for ages, as to why this is not happening. And it has to do with key value coding not working automatically, you could say. So what we are actually going to do is go back into our app delegate, and right around this jobs change, so whenever we add the object to the jobs, we need to basically have a way of informing our array controller that we did something. So to do that, we are going to say to the key binding system, we're going to say that we will change the value for the key jobs. This is going to tell it that, hey, binding system, we're about to change this. And then afterwards, we will actually change it. So we can say we did change it for jobs. And if everything goes smoothly, this should update our queue window to actually show an item in there. No, it did not. This is where I start getting nervous. I have no idea what I'm talking about. So let me verify. So the whole reason that I did this beforehand is so that way I could have a reference to actually check back on in case I do run into problems like this. But basically, we should have most of everything hooked up. So that's hooked up to jobs, right? So let's double check together. So we have our array controller that is hooked up to the delegate and to the jobs path. I don't know why it's saying there's an error. Yeah, so that does not matter. Now we want to make sure that our table view is also hooked up. So we can go to our table view, our queue table, and check the contents are correctly hooked up. And that's connected to arranged objects. Okay. Then what we might just need to do is update our table view. So in order to do that, we will need to have an IB outlet, which is going to be a reference from our code to our interface. So to do that, we are going to open up this and this at the same time. Well, the screen is small. Assistant editor. All assistant editors on the bottom. Okay, this should give us a tiny bit more room. But let's go ahead and make a reference to our queue table. Is that what I called it before? So we stay consistent. Yeah. So we'll keep our queue table right there, and we'll go ahead and refresh it. And hopefully that should be enough to like kick it back into shape. Refresh. Oh, forgot that underscore. Did I mistype something? This is an NS table view. Queue table, is that coming through right? Yeah. And is it not refresh data? Am I getting confused with something? This is what happens when you reload. There we go. Dyslexia. Fun thing to have. Tricks you into thinking that you know something and then it's like slightly different. So let's try again. We'll select an object. We'll say open. So it's still not working. So let's go ahead and debug this because that's the process of developing applications, right? So we'll go ahead and stop here. And this is immediately after we open the file. And let's make sure that we at least get to this point, right? So we'll go ahead and say open. We'll choose our small. And this brings us to, okay, let's try that one more time, but we're gonna move that open dialog so it doesn't make everything white. So we'll do that, say open. So now we can step through and see exactly what the program is doing. So we can see that did launch is in fact yes, so this is gonna be skipped. So if we go down, that's gonna get skipped. Our asset is getting created, so we have a valid asset. And we're going into there. Let's see if we're gonna, okay, so we're making our job. So that's all valid. And we'll skip over these because they're not doing anything interesting. Let's go into add job to queue and make sure that's being added. And we check, oh, and our array is nil. So that could be a problem, right? So we're adding, this is a feature of Objective-C actually, where if you can send messages to nil and it won't crash. Unfortunately, it won't tell you either, so you have no way of knowing. So both of my arrays are nil, so I'm doing nothing essentially. Our queue table is of course there, so let's comment this out because I'm not sure we need it. But let's go ahead and actually initialize our variables, so that way we can actually add stuff to them, right? So in our app delegate, let's make a constructor and initializer. And in Objective-C, the standard way of doing this is to basically get the super classes initializer, which in most cases will set most things up for you, and then you basically just do your changes. And then we'll return ourself if there were no issues that we saw. So in this case, we won't see any issues because we're just allocating basic arrays. So we're going to make a mutable array to represent the queue. So this is why it's important to initialize everything and not just declare it, because if you just declare it, it doesn't mean anything. And we'll also make our jobs object. Okay. Okay, so let's see if we do need to refresh that table. I don't believe we do, but we might. So we go there. Let's just go ahead and continue. And there we go. So we have an object. And if we want to be cheeky, we can open up another job, and that should add another object there. So this is connected. Nothing else is connected yet, but we'll do that at a later point. At the very least, we can show information now. Grab some water. So now we actually, with most of the rest of the app set up, we actually want to start messing with the video. So let's declare first in our header a method that's actually going to start the work of our job. So we'll just call this start. It doesn't need to be fancy. Start. And then planning ahead a bit, I also want to make a delegate that the job can call back and inform whoever called it that the job finished. So that way, that way we can go ahead and clear out the queue. That makes sense? So let's make a property to represent our delegate. So delegates, excuse me again, delegates should always be weak, have a weak reference to them, because they oftentimes hold a reference back to a parent. So in this case, the app delegate's queue is going to hold a reference to the job, and we don't want the job to hold a reference back to the queue because that's going to make a retain cycle. So what we're going to do is we're going to have a weak reference back to whoever the delegate is, whether it's a queue or something else, so that way we don't run into that problem. And if the delegate disappears, that's okay. So what we're going to do is we're going to make a job delegate. So I'm just going to type it out so we don't have to come back and say delegate, and Xcode is going to complain, but I don't know what a job delegate is. So we're going to make a protocol to represent our job delegate. And there are many different ways of doing this. You can declare the protocol after the class. You can do it before. Since I'm doing it before, we're going to have to tell the delegate what a job is because it doesn't know at this point. Delegate. So we have a job delegate protocol, which is going to have one method. It's going to be void job did complete, and it's going to return back the job that completed, so that way we can cross-reference. And then we're going to say with error, so we can be nice and give errors to the user if there was an actual error during the process. It's usually a good idea to plan ahead like this when designing an API, so that's what we're doing here. We're designing this API. But right here, Xcode doesn't know what a job is because, lo and behold, a job is defined after the protocol. So we need to say, hey, Xcode, don't worry about it. We do have a job object, class, not class, job. And now that makes Xcode happy, and everything should be able to compile. So here we're referencing this guy. So since this is before this, it's happy. If you were to declare the protocol afterwards, you would need to do @protocol job delegate semicolon instead of @class. You have to do one or the other. So this is one of them. And then we can go here and tell our job to start. So I believe we're going to do that right after we make it. So we're going to, no, right after we queue it. So right here we left a comment. So we're going to say self start, not self, current job start. And then we also want to use our delegate to good use and clean up after our job completes. So that way we can go and do the next one. So we'll first declare that we do conform to the job delegate protocol. So that way the job can see us and be happy with it. And then this will magically autocomplete for us and let us say that the job did complete. Job did complete. And we can go ahead and do something once it's complete. So we're not going to use the error just yet, even though we made one. But if you were to flesh this out into a user-facing app, the error is there for you to use. And you can also use it for debugging if you want to put a breakpoint here. So we're going to clear out the current job, and then we're just going to tell it to queue the next job. And this should take care of that. So let's see if that works. So by see if that works, it's not going to do much, but it should just add the job and not crash. Let's get rid of this breakpoint because it makes it hard to see when the open panel is there. And here it is. There's our job, and it started and it never completed because we didn't define what it meant to start. And actually, we just declared the start method, but we didn't actually implement it. So we have a handy dandy unrecognized selector sent to instance blah blah blah. We actually have job start, so it does tell you some information. So that's what this error code means if you ever see it. And then it's going to go ahead and tell you where that happened so you can follow all that. So it happened in app delegate queue next job, so you can figure that information out little by little. But here we know the reason is because we didn't go ahead and have an actual implementation for job yet. We just kind of said, oh, hey, it has a start thing and it has a delegate thing, but we're not doing anything. Talking about delegate thing, we did not assign the delegate. We should do that. So right here, when we add a job to the queue, we should be going and setting up the delegate. So we'll say job.delegate equals self. So this will set us as the delegate, and then it will do the rest of it. So we figured out we don't need that. And then I plan to, at this point, to set up the job. So currently there's no parameters, so it's all fine, but I'll leave a reminder, set up the job. This series was originally live streamed, so we split it up into 30-minute episodes so it can be uploaded. Since it does take more planning to make this kind of content, we don't plan on producing it very often, but if you do enjoy it, please subscribe on YouTube or Twitch and let us know in the comments below or on Twitter. Thanks! Bye, Chen-chens!